Okay, so I am recording now. We have finished last week. We did unit 1, which means, sorry, I see a question in the chat there. I'll get to that in a minute. I don't want that on YouTube. Let me write here. Okay. Okay, sorry, I just had to write a message in the chat. So we will start today with Unit 2. Last day we talked about, the definitions, the difference between alkanes, alkenes, and alkynes. And today we're going to get into maybe your second most important unit. So let me go to the next slide. This, and okay, I should say especially these two topics. We probably won't get into this today, but this is by far the most important topics of this course. Chapter 5, we're going to apply hydrocarbon chemistry to other topics. So we'll talk about, what you might see in the field, what you might see on a work site. So some of you might already work for RasGas or Qatar Petroleum or whatever. We'll talk about that in Unit 5. But these two topics are so important for this course. And we might not get to them until Tuesday, or looking at my schedule when I see you tomorrow. So I'll see you guys on Wednesday morning, actually. We'll talk a little bit more about this on Wednesday. So today, just an introduction. So I'm going to get into definitions. We'll talk about hydrocarbons, saturated and unsaturated, and we'll see how far we get. So let me open the chat here. And thank you, Niam. I will definitely try. It's going well. It's been a few weeks or months. I'll definitely try and quit. But we talked about this yesterday or Thursday, what a hydrocarbon is. And I showed you this picture of an old early 1900s oil well. You should know what a hydrocarbon is. So let's move into this. IUPAC, which is, and I should hit record. Okay, I'm recording. This is the international, don't mind my writing. Oh my gosh, that's bad. Let me do that again. That's real bad. Let me fix that. The International Union of Pure, let me fix this, pure, oh my gosh, my pen, and applied this is taking forever. I'm so sorry. So this is the International Union of Pure and Applied Chemistry. I'm so sorry my writing is messy, but IUPAC are, and like I'm going to talk about them a lot in this course. They are the people. They are the organization the people we care about when we're naming hydrocarbons or ionic compounds or anything. So hydrocarbons defined by IUPAC, Worldwide Union of Pure and Applied Chemistry, they classify hydrocarbons as three things. We have saturated, unsaturated, and aromatic. And aromatic, I'll talk about this in a minute, but just remember this chemical is what we would call a benzene ring, or a ring, an aromatic structure. So, saturated hydrocarbons. These are the simplest of all hydrocarbons. No double bonds, no triple bonds, no benzene rings, I should say. It's single bonds. Okay, and the reason, and this is maybe not the most specific definition, but for me, when I hear the word saturated, saturated means like completely covered. Completely. In Canada, you would hear the word saturated like if you were soaked in water. Saturated meaning completely covered. So a saturated hydrocarbon would have complete coverage of hydrogen. So what I mean is, let's look at butane. This is butane on the bottom. Every single hydrogen or carbon, would be covered with hydrogen. You don't need to write this down or know this or anything like that, but the idea is if you have single bonds, all of those carbons are completely saturated. So here are some examples. You see this is propane, which if you guys like to cook or you like to barbecue or grill, you might have a propane stove. This chemical is 1, 2, 3, 4, 5, 6, 7, 8. This would be octanol. Another hydrocarbon, it has all single bonds. This 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. This is a chemical you do not need to know how to name. This is a carboxylic acid. But again, all you need to know is that a saturated hydrocarbon has single bonds. There's no double or triple bonds here. Unsaturated hydrocarbons, these are where you see double or triple bonds. Oops, sorry, dropped my pen. So these would be alkenes or alkynes. I have examples over here, but in simple definition, you would have like a double bond, or maybe you would have a triple bond. These unsaturated hydrocarbons are chemicals that have more than one bonding. So here are some examples. This is ethene. This is ethine. So the end of those words are telling me that ethene has double bond, ethine has triple bond. Something like ethane. Ethane would be written like I'm going to try to do this. Hold on. Give me a second here. Oops. Sorry. F-ine would look like this, and it would just have a single bond. F-ene, F-ine, or this chemical. This is, I picked a more fancy one, a more complicated chemical. This is linoleic acid. This is what we would call an alkyne. So when we see these double bonds here, two letters, or two lines, sorry, it's an alkyne. And I'm almost done. I just have a chat message I'm trying to open. Oh, so Niam just mentioned in the chat, if you guys are reading the chat, do I ever get annoyed at the pen? I am annoyed at this pen every day. And this pen is Microsoft brand, the most expensive pen you can buy. I have a Microsoft Surface computer, and for some reason in PowerPoint, it gives me issues and it drives me crazy. So to answer Niam's question, my gosh, this pen is my worst enemy. I love it and I hate it. So the last thing today, and tomorrow we will get into this. Tomorrow's class will be really important, but the last thing to mention, I'll give you 2 slides and we're done, is the difference between aromatics and cyclic. And this is really important. This slide and this slide, really, really important that you guys know this. Aromatic hydrocarbons, and I talked about this last week, they both have what you would call a benzene ring. In chemistry or engineering, we call this benzene. This ring is not the same as a cyclic aromatic. So aromatic hydrocarbons, they call them arenes. We won't talk about, I don't personally use this word. I say aromatic. These are hydrocarbons that have one aromatic ring. So what the heck is an aromatic ring, right? And this is really, really important for you guys. An aromatic ring. So like I can have this chemical. Sorry about my pen. This is called cyclohexane. It's cyclohexane because I have 1, 2, 3, 4, 5, 6 carbons. So this is not a benzene ring. This is what we would call a cyclic or circular compound. I mean, I can pick anything. This 5 carbons, don't mind my writing, I'm not the best writing. This would be cyclopentane. 4 carbons, it makes like a little box. This would be cyclobutane. Okay, so these are not, sorry for my spelling here, it's my pen, it's not me. These are cyclic, but they're not aromatic. Aromatic has a ring. And sorry, I said that a little silly. Aromatic has a ring, but it also has on every second carbon a double bond. So these are aromatic compounds. The double bond, let me erase that. Let me pick another color here. My favorite color, purple. These double bonds, these make an aromatic ring. So these are what we would call aromatic. And like I mentioned the other day, they have a smell. They're typically in food compounds or very smelly compounds. These are what makes it aromatic. And some of you might be wondering, like, okay, what about this compound? Like, what if I drew cyclohexane, but I put one double bond there, not, 2 or 3 double bonds? This is not aromatic. Aromatic literally needs to have 1, 2, 3 double bonds. It looks like this. So guys, I think that's it for today. I know I talked a lot or rambled. And thank you, Naeem, for telling me I wrote it perfectly. I'm just looking at the chat here. That's enough for today. And tomorrow we'll talk more about cycloalkanes. And honestly, tomorrow, if you come to class tomorrow, we are going to get into naming. We're going to learn how to name hydrocarbons, alkanes. Tomorrow is a really important class. So, I say tomorrow, sorry, you guys don't have class until Wednesday. So I hope I see every one of you. There's 13 people here. I hope I see you all in the lab tomorrow morning at 7:30 a.m.